Okay, we are going to work on areas and volumes. There's
Are we doing just 6-1 or 6-1, 6-2?
just 6-1, and the parametrics are in 6-1. Okay. So there's some vocabulary here, but first let me tell you that on the exam, because of the fact that a graphing calculator, okay girls, a graphing calculator can make this easy for some students, and all they evidently have to do is type in the equations and it'll find the area for you. They have removed this from the free response part of the exam. So now this is in the non-calculator part. So that even the problem I gave you, you should be able to do. That last one. Also, last year, girls, the BC problem, area problem, was different than the AB area problem. Okay? So that's not always the common problem. It always has been. Last year was the first year where I didn't see that happening. Okay, we don't have to do differential equations because we haven't done those yet. So we can cross that one out. That's in Chapter 7. And so what we're going to do is Chapter 6, polars and vectors before break. I know it's a lot. I know you're ready to be out of here for break.
We were finishing Chapter 6.
Yeah, you do. Those are the parametrics. Yeah, but there's not very much. Oh, those are the other kind of vectors, the math vectors with dot products. We don't have to know that. We have to know about vectors in terms of physics.
I think there's a date, 3:39.
29. Probably just typed it wrong. I hope. Okay. So we're going to, if you look at the schedule, we should be through all of that. It's going to be pushing a little bit. You're going to find the polars difficult. Polars have not been on the free response part of the exam for a while. I strongly believe that they're going to be there. I thought last year, but they weren't. And I think this year, I think they will be. I would think so. If you go back and I'll print out the spreadsheet for you. You start looking at the patterns there. It hasn't been there for a while. And then we will finish up on the Wednesday. Sorry, it's Tuesday, Wednesday, right before break. Oh, no, I'm not doing that in AB. We're doing it the week before. We can't get it done. We can't get it done. We can't get this all this material covered unless I test those last 2 days before break. I don't care. I'll put the grades into fourth quarter. I don't care. That's not the issue. The issue is I want it done before spring break so that you leave here, you have nothing to think about except for maybe practicing AP problems, but that's your choice. It's a great idea, and that's your choice. You would come back like on the 8th or something of April. We'll come back pretty late. And then we have to do Chapter 7, which is not bad. And it picks up some more BC topics. This is going to be your toughest unit that we have left to do. And then we're done. It is, but the polars are tricky. The vectors are not bad at all. We've been doing those all along. Okay, so we have to do, what are the BC topics? Parametrics, the volume is exactly the same as AB. The area is the same as AB. Average value of a function, that's the same as AB as well. Arc length, well, I'll tie it in with vectors, so it actually relates to that. And then the polars and the vectors, and that's going to be tough because it's a different way of thinking. So that's the schedule. Won't have a snow day, maybe we should have a Sunday, but... What is an integral? Okay, it's a signed area under the curve. Now, I don't know how many of these we need to do, or I can have you try them first. How do you find the actual area? You'd have to do the absolute value of your function if it drops below the x-axis. Okay, so if it drops below the x-axis, we have a problem. This one's fine. And what I like to do when I do my areas and my volumes is I like to show the slices. I'm going to integrate or find the area between -1. No, I don't like that one. From -1 to 2. That's the actual area, just like when we had distance and displacement. Displacement was the integral, but distance was the absolute value of the velocity. So I want that little area, and I tell you, what I see students doing wrong on the exam, when have I graded these? Yeah, I did. They don't want to put the differentials in. Well, the differentials are what tell you what variable you want. So when you don't do that, you start rotating around other axes, I can see why you would get confused. So I like to draw a little slice in there. And we'll slice it vertically. As you know, we can slice it other directions. And there's a whole bunch of these rectangles we can put in there. And if I put an infinite number of them in there, I will fill the whole thing up. And that's called a what? It starts with an R. Riemann sum.
Did we just learn this?
Yeah, well, this is an application now. So where do we use integrals? We use them to find areas under curves. I can, yeah. Okay, so Riemann sum is you're going to add up all the heights. Well, guess what the height is? Height is equal to f of x. So it's going to be the limit as n goes to infinity, just to do this quickly. And we'll count from I equals 1 to n. I want an infinite number of rectangles. And it's going to be the height of the function at each x value times the base. And we could do that. We could actually draw in all the rectangles. And we did. We did trapezoidal rule, and we did some other ones with Riemann sums, with the midpoint rule and such as that. And then Riemann says, I don't want to write all that stuff out. That's too much to write. You agree with him. You hate writing all that stuff out, too. So the German word for sum is S-U-M-M-E. And that little s kind of looks like an integral. And this is my guess. He decided, well, let's just write it as an s. And so it's f of x dx from A to B. That's a definition. How do you find the area, the signed area? Using the fundamental theorem of calculus, that's equal to the antiderivative evaluated at B minus the antiderivative at A. So guess what? This is no different than what we've done. So I like to find the differentials first. Is this going to be delta x or delta y? And it's geometry. Do you guys see that? It's delta x. If you drop your rectangle, it hits the x-axis. It's just a cheating way to remember. But that's the thickness. It's delta x. So the area for one of these slices is equal to delta x. That's the base. And how do you find the height? It's this y value minus that y value. Well, what's that y value? 0. So it's y1 times delta x. And because x and y are perpendicular, these letters will always be opposite, or different. So to find the total area, I take the y values. I'm going to integrate with respect to x from A to B. That's just the general form of it. That's all it is. So parametrics will follow from that, actually. Okay. What do I have to do? What letters do I have to have in this integral? I have to have x's. So you're going to have to make y equal to f of x. So in this particular case, maybe this is a good one to remind ourselves how to integrate with a calculator. I'm going to integrate, what is my y value here? Was it x squared plus 1 or something like that? Now, on the exam, if they have this written out like this, you could just write f of x. That's perfectly okay. Or g of x, whatever it is. So it's x squared plus 1 dx, and now what are my x values going between? Negative 1 and 2. This is the type of problem they would expect you to be able to do by hand. It's honestly not that hard. That's easy, isn't it? Now, do you remember how to put it on your calculator?
Yeah.
Kiddos, do you remember how to put this on your calculator?
Maybe I can't touch this.
It's, well, you all need to. Now, I put this into y1. Okay, guys, here's the other thing. There it is. There's my calculator notation hidden into this problem. And it's okay to write your calculator notation on the exam. However, you better give them the real integral. If you tell me what y1 is, y1 equals whatever the function is, fine. But they don't, and they won't mark it wrong when you write FNINT, but they won't give you any points for it. X, comma, and it's A, comma, B. I always put it in my y variables because I don't want to mess up with the parentheses. This one's easy. I wouldn't have to. X, -1 to 2.
What do you call it? Like pretty
print.
And the pretty print will look like pretty print. So let's go ahead. I have my calculator up so we can do this.
Let's go this way. I think I did have.
And that's what I really like about it. And the Inspire is all in pretty print, the new one. The old one, with the new operating system is too. Okay, so y1 was x squared plus 1. So I like to put them here. By the way, does it matter what the variables are?
No.
No. Okay, so then I'm going to quit. And I'm going to go to math. And I'm going to go to 9, F-N-I-N-T. And there's the pretty print. So it looks just like what I need. The only reason I like it is because on the exam, I'm not going to, if I have it this way, I'm not going to mess up writing it on the exam. That's another good reason to have this. And that's 2. The Inspire works a little different. Just a little. And then that's going to be y1. Now, remember how to get y1? It's bars. It's a y variable. Girls, you're the ones asking about this. Function. And then I have to arrow over and put in dx. And that looks just like my generic problem. Okay. It will not be a calculator problem this year. Guaranteed. You still have to know how to integrate on your calculator. Guaranteed. Now, if you did this one, and I'm sorry, but that picture is wrong. This is at 1. We'll just fix it. This is at, that's at 3. I think it's at 4. Oh, I don't care. We're going to put the line at y equals 2. Or x equals 2, sorry. So you really want this piece. And then this. So how are we going to do this? Okay, girls? How are we going to do this one? We're going to integrate f of x dx, because you know it's dx, right? And we're going to integrate from where to where? This point, which is at -1, to where? Not 2. 1. You have to integrate the positive part, and then we'll integrate from 1 to 2. But what's wrong with that integral? It's a negative number, so what do I have to put here? Minus. If it's a calculator problem, which it won't be, it'll be -1 to 2. Now, it could be a calculator problem on the multiple choice. That they might do that. And you could cheat a little bit and just do the absolute value of f of x dx. If you want the full video, I don't think I have you in there. I can bring in the AB video, which has the whole thing on it, showing you how to integrate it and everything. Or is this okay for you guys? Yeah. Okay. Set this one up. Okay, girls, set this one up. I'll do this one. Which one's which? Should we call this one f of x? And then the other one, we'll do Christmas colors. It looks like a parabola to me. It's g of x. Okay, and let's call this one x1 and this one x2. Yeah, I had to label it though. Oh, you can work on the other one. I'm just going on.
Okay, fine. No, it's fine.
No, because you know how to do it. At least I think you know how to do that. You're the one that doesn't like to review the AB stuff. That's funny. Okay. What about this one though? Because there's nothing really much to do here.
That's x minus g of it.
So we integrate
A to B.
from A to, well, there's no A and B. It's x1 to x2. You can make it A and B, it doesn't matter. And which one is the bigger one? If I show my slice, f of x. The problem is going to be when we rotate it and we have to slice it horizontally. So it's f of x. We'll worry about it today. dx. If we get to everything. This is hard? It's easy. It's geometry.
That's the same thing as doing f of x minus
We should do the
the integral of f of x minus the integral.
Correct. The question is, and honestly, I see this in AB, that a lot of my students don't realize that you can distribute this integral and break it into two integrals.
I remember on the A/B test there was a problem like this, and then I was really messy.
And there will be some that are harder. Now, you guys, this is the distributive property of integrals over addition subtraction. Okay? Okay, girls, you're missing this. Can you distribute an integral over multiplication or division? Marcus, can I distribute an integral over f times g? Is this true? Is that equal to the integral of f times the integral of g? No. This is the distributive property of integrals. And one of the problems we have with this is you tend to think everything distributes over everything, and things don't. What about exponents? Do exponents distribute over addition? In other words, is that a squared plus b squared? No, but integrals do. If you think about it, it is. But now, integrals don't distribute over multiplication, but what if can I distribute my exponent over multiplication? Yeah, that's a squared times b squared. So we as math teachers need to be more particular about our vocabulary. You can't just say distributive property, because it depends on what you're doing. Some things can't distribute at all. And you'll learn in upper level math you can distribute scalars over matrices, if anybody's done anything with matrices. They're actually easy. Okay. There you go. Find that area. Now, this is the type of problem that they would expect you to be able to do by hand.
Okay, let's actually do the problem.
The curvy thing. What's the curvy thing called?
I know that. The parabola.
Okay, on the exam, it's perfectly okay to, now you're not going to write it on your exam, on the test copy, you're going to write it in your work booklet. I got to find those pictures. I have pictures of...
Pause the recording.
So we're going to put in, right in here, x plus 4. Is that f of x or g of x?
That's G of X.
That's g of x. And this is, what? F of x. So if you do this in your workbook with that you're turning in to be graded, that's fine. Then all you have to do is write f and g. Except that you have to integrate this one, so you might want to write it out. So we're going to let you guys, I'm going to pause. Does everybody agree those are the intersection points? Okay, and then because we're going to integrate it by hand, I better write in what these things are. So it's g of x, which is x plus 4, right? Minus x squared minus 2. Now, do you want to Combine that first or just integrate and then combine? Okay, so it's the integral from -2 to 3. Let's see, what can I combine? X minus x squared. Now that's 4 minus a -2. So it's plus 6. A lot of places to make mistakes. And so the antiderivative is x squared over 2. And make sure you go the right direction. Some people are taking derivatives. Minus x cubed over 3 plus 6x evaluated at -2 and 3. So what's this going to give you? 9/2 minus, whoops, no, 27. Oh, okay, you just want to 9. Okay, that's fine. And that's plus 18. I'm very particular about this because I want to get it right. Minus -2 squared is 4/2. Now, -2 cubed is -8. That's correct. It'll be plus 8. And then it's going to be minus 12. Do I need to go further for the graders?
I want you
Oh, we will, but do I need to?
to.
No.
You really don't?
And don't. So this is 9 minus 9/2. And then let's see, it's minus 2, minus 8/3, right?
9 minus 9.
This is 9. Oh, plus 9. Right. And a minus 12 is plus 12. So 9 minus 2, 7 plus 12 is 19, plus 9/2 minus 8/3. Common denominators. So I'm going to get 19 plus 27/6 minus 16/6. 19 plus, what is that? 11/6, which is easier to do as a mixed number. It's almost 2, it's 1 and 5/6, right? Which is 20 and 5/6. 125/6. I guess I'm remembering a different answer from a different problem.
Yeah, no kidding.
Happens.
Don't be for such anger.
Okay,
Peter.
remember, that's good enough.
No,
That's
but
important.
I got the right answer.
Good.
25 divided by 6 is 29.
But you're going to check it with your calculator. Try that one. Now, girls, what am I going to do with this one? Which way do you want to, you guys, which way do you want to slice this?
Let's do the
Now, if I do it vertically,
minus
Why?
okay, you guys, if I do it vertically, I've got this one, and I've got that one. This is the curve minus 0. This is the line minus 0. Too much work. Because we don't have to slice it vertically. We can slice it, oh, I'm still set. You can slice it horizontally. That's okay. Remember doing that? Because then it's only one integral. Sometimes they set it up so you have to do 2 integrals no matter what you do. The other thing that will dictate what you choose to do is whether or not you can solve for y in terms of x or x in terms of y. Because what's the differential here going to be? What's this length? It's the change in y, right? Okay, so I'm going to take this x coordinate and this one, and how am I going to find this length? Subtract them, right? So it's the integral, which one's bigger? x1 is minus x2. And what I don't like about the set up but do not integrate, which they could easily do on the non-calculator part, they could do that. I haven't seen them do that lately, but I don't like it because there's no way to check to know if you did it right or wrong. Because if you get a negative answer, you did it wrong, right? And this is dy. Which variable do I want in this problem? I want the y's. This tells me. That's why the differential is critical. It tells me I want y's. So I have to solve for x in terms of y. Had I had y equals e to the x plus the sine of x, Could I solve for x as a function of y? No.
It would totally do that.
They would, and then you'd have to slice it vertically. Just one's going to be easier than the other. Sometimes it's not even possible. So, but luckily we're not doing that. It says y equals the square root of x, so therefore x equals what? Y squared.
The absolute value.
No, that's when you square root, not squaring. Okay, so y equals minus x plus 6. Solving for x, what's x going to be? Can you do it in your head? 6 minus y. And Mrs. Herman suggested, and I really like that, I had never thought of that. Instead of even using f and g, we can use x1 and x2. x1 goes on the line, so this is x1, and this is x2. So if you put it with the functions themselves, this was x1, so x1 equals y squared. This was x2, so x2 equals 6 minus y. Then it's easier to do. Okay, so it's x1, which is y squared, minus x2, which is 6 minus y. You don't want to factor it, you just want to integrate it. dy, and then I obviously can find this. What's y equal to here? 0. Make sure you get the right variable, because these are y's. That's another thing I've seen. Students will give me the x values. I want the y values. So then I have to find out where they intersect. Probably if I set these y's equal, that might work, or do you want to set my x is equal? X is equal is easier. Y squared equals 6 minus y. And then what do you do with that? Marcus, you know what to do with this one? Y squared plus y minus 6 equals 0. What do you do with every single equation you solve? You set it equal to 0. And then you factor this. So it's y. Remember how you guys were a long time ago? When you first started factoring, and even in AB when you came in, it was still shaky. And now you're just kind of, well, for a lot of people it is. Okay, so my solutions are y equals 2 or negative 3. I will tell you that when my daughter went to the University of Minnesota at UMTIA, if she started with this line up here and went right to that line there, she lost half points,
Question.
half credit.
You do it backwards by any chance? Like 6 minus y?
No, you can't. It was,
Yeah, I
It was-
think that you did it the wrong order.
did I do it the parabola wrong?
Or if you do it the other way.
I did do it wrong.
Yeah.
But if I do it, I'll find out that I did it wrong because I'll get a what? Negative sign. Why did I, x2, I missed I marked it here wrong. Sorry.
It's kind of ironic that the trick that's supposed to help you remember.
It was, yes, because I put the 2, I should have put the 2 there. There we go. And there's the 1. So I can fix this. I'm on the exam. I messed up. By the way, which is it? 2 or 3? No? It's a 2. And what am I going to do here to fix the problem for my readers? Or I could do that. Any of that's correct. That's still a correct answer. And then we could integrate it. But I'll get a negative answer. Why isn't where's the negative 3 coming in? Because it is there.
It's going backwards.
Well, it's the bottom half of the problem because this is not a function. And so this is where it's intersecting over here.
You said y equals square root of x is actually the absolute value of x equals y squared. Which
No, x equals y squared.
No, absolute value of x equals y squared.
Right,
Because you can't take, so absolute value.
right. So it's the other half of it.
Is x equals plus or minus. So therefore,
I can't find the inverse of y equals x squared because, without restricting the domain, because of the fact that y equals x squared looks like this, and its inverse looks like that, which is not a function. So if I restrict the domain and just take half of it, then I only get half of it, which is what they did right there. Okay, now, let me check my time. Oh, there's no time. Okay, let's at least, we'll do the parametrics first thing tomorrow, and it's going to work out really nice because it's going to go fast. So,
You know, I'm gonna take
it,